Don't shoot. So welcome to Percenters to another episode in the Diagnosis and Understanding series. In this episode, we are going to cover the fundamentals of understanding and diagnosing an A.I.R system, also known as air injection reaction, secondary air injection reaction, A.I.R, and in some places they call it a smog pump system. But either way, it's very often overlooked. First of all, many cars do not have any kind of A.I.R system involved with it. And second of all, as usual, there are many different varieties of components and theories of operation in different A.I.R systems. But again, the basic understanding of one system should lead you to being able to diagnose another system. So as usual, this is just going to be a primer on the system. If I come up with a car that needs an actual diagnosis of the system, I won't be going into the theory and background and basics so much. I will just do the diagnosis in that video and refer you to this one as a primer for the background that you would need. And as a matter of fact, I did just recently look at a truck that does have a A.I.R system code in it, and the basics that we're going to go over here passed on that truck. So I decided we're going to bring that truck into my garage within the next couple weeks and do an actual A.I.R diagnosis. That should be a pretty good case study, but you will need these basics to understand it if you're not familiar with the system. So let's head over, as usual, to the dry erase board of knowledge, get the basics down, and then apply those basics and theories of operation to the actual car, which in this case I will use my Trans Am. I've never actually really looked at the A.I.R system on my Trans Am, never had a problem with it, but I know it has one, so we'll see how well our theory of operation fits on an actual application. So what is an A.I.R system anyway? So the A.I.R system is one of the many emissions control devices on a car, and this one actually works to help control emissions until engine warm-up, more specifically until exhaust and catalytic converter warm-up occur. Basically until closed loop operation or the operation of the oxygen sensors is initiated. So the idea is during warm-up, as you well know if you watch the Diagnosis and Understanding series and other videos, the engine warm-up is a particularly troublesome time for controlling emissions because your catalytic converter is not warmed up. It needs to be at like 700 degrees or so to be fully up to snuff to clean emissions. The oxygen sensors are not adjusting fuel trims because they have to be up to temperature. So the A.I.R system basically helps in two ways during this period of time, from open loop or non-oxygen sensor operation to closed loop, or the time that the emission systems and engine control systems do take over in the car. During open loop, the air pump will operate to, at appropriate times, inject air into the exhaust stream after combustion. The chemical reaction from the extra oxygen in the exhaust helps to oxidize the pollutants and help to control some of the noxious outputs that would come out that normally would be cleaned by the catalytic converter, which of course is not operational yet. So that's one of the first things it does. The second thing that it does is the act of injecting this air into the exhaust system increases the temperature so that you get a more quick and efficient warm-up of the catalytic converter and the oxygen sensors and components of the exhaust so that you do get into closed loop sooner. So those are the two functions of the A.I.R system. So let's go ahead and look at a typical A.I.R system on the diagram here on the whiteboard of knowledge, and then we'll go ahead and compare how that looks and how we would test components on the actual car. No, this is not a diagram of the pig circulatory system. But what we've got here is in blue is pretty much the standard vacuum and air passageway components of the A.I.R system, and in red would be your electrical. So this is just kind of a standard drawing. Again, there may be variances in your vehicle, but it will generally be the same in design and operation. So we'll start here with the control for the air pump, which is here, which actually drives the air into the system. There will be a relay, which in my experience, everyone that I've ever seen is ground side switch controlled by the PCM. Of course, you will have inputs in the PCM, particularly coolant temperature sensor or other indicators that would let the PCM know that the engine is not warmed up yet. So other open loop indicators will activate the air pump system, usually during idle conditions. You don't really need the air pump system when you are heavy on the accelerator. As a matter of fact, hitting the accelerator should actually turn off the air pump system. It's one of the diagnoses you can do. But anyway, during the colder temperature sensor input, the PCM will activate the relay, turning on the air pump as well as a solenoid up here, which I didn't draw the connection to. But the air from the pump will go up to a control valve, which normally would be closed to prevent air from coming into the system when unwanted. When the solenoid is open, vacuum will cause the control valve to open. So it's a vacuum control solenoid. And when the vacuum is applied to the control valve, I think also some systems call it a diverter valve, that will allow the air to come directly through these tubes past check valves. The check valves are to ensure that the air direction only can be towards the exhaust manifold, so air can only go in one direction. This way, exhaust from the manifold cannot back up into your air system, possibly causing damage. And then the air enters the exhaust manifold directly and causes the activities that I mentioned earlier. And these, of course, here would be your cats. And, of course, in my car, Schrodinger's cats. So some things to know about this system. Very, very commonly, the most common thing, at least that I've seen on failed air pump systems, is a bad air pump motor. Now, does that mean that if you have an air pump diagnostic trouble code, a check engine light code, that you change your air pump motor as your first step? Only if you're an idiot. So obviously there are many components here that could potentially be causing problems with the air system, and understanding how the PCM reacts to knowing that the air system is working or not working to throw that code is of course integral to diagnosing the problem. So let's talk about that a little bit now. So how does the computer know that the air injection system is working? Usually, on most every system I've seen, it really actually only does it one way. It doesn't actually have direct testing of the solenoids and things like that. So really, there's very few check engine light codes for the air injection system. I think they're usually going to be something like, trying to remember what that truck had, like a P1415, something like that. You may, because the air system runs to each bank, a little clue here on how it works, it may detect whether air is working in one bank or the other. So you may have like a P1415 for one bank and a 1416 for another bank. But all these are clues on how the PCM would know that the air system is working. So if you are familiar with the operation of oxygen sensors, and if you're not, by the way, a really good video to catch you up to speed on why oxygen sensors would be used to determine air operation would be my P0420, P0430 diagnosis video where I talk about this. But if you do know about oxygen sensor operation, it should be very obvious to you that at your oxygen sensors here, you would be at your stoichiometry, but the injection of air directly into the exhaust after combustion, so it's not accounted for by the fuel trim, the injection of air into the exhaust should very quickly lean out your oxygen sensor stream. This, of course, would be reported to the PCM, and then, of course, when the air system turns off, the system should, of course, go rich for a while. And that rich condition, when the PCM turns off the solenoid, is repeated. So when the PCM turns the air system on and it sees the system going lean from the O2 sensor, and then the PCM turns the air system off and sees the rich response, that is how it knows that it must have worked. Now, some of you guys I know are extraordinarily perceptive, and you are thinking, that's great, except for one problem. This cannot be occurring because the air system, as I correctly mentioned, is operational during open loop. So there would not be feedback from the oxygen sensor, and you would be correct. So think about it. How does this work then? Because this is actually how the PCM knows. How does this work if the air system is supposed to be operational in open loop? So the answer is ridiculously simple. Nobody said that this test has to occur during open loop. What actually happens is this test of the air system will actually occur at some time when the engine is known to be in closed loop by the PCM so that it can see these responses exist. Now, hopefully you're noticing as kind of a pattern with this Diagnosis and Understanding series that you can never really master one system without knowing other systems. You can't master the air injection reaction system without understanding open and closed loop and oxygen sensors and feedback and stuff like that. So hopefully this is making sense to you that you really have to understand all automotive systems to even understand one. All of these are always connected like this. So let's talk about diagnosing some problems that are common with the air system and how you would do it before we get onto the car and take a look at this system. But typically, in my experience, the most common failure is the air pump itself, often water getting into the air pump and corroding it beyond recognition. So does that mean, of course, that if you have an air pump code, you replace the air pump first? Well, only if you're an idiot. But the 2% of us that would never do such stupidity because we recognize that there are many components that could fail, and the fact that the code is going to be pretty general and not really help specify which of these components could be failing, we would never do that. But it is a good starting point to check your air pump, and I will, of course, show how to do that. After that, a lot of times a electrical problem or a solenoid problem could be the cause. I usually find it easier to test the solenoid, and after that, the electrical. Obviously, it goes without saying that any kinds of leaks or opens here, particularly with the solenoid, because those are going to be very thin tubes, that would, of course, cause failure of the control valve to operate. Also, you might have any kind of vacuum leaks from the system if this occurs up here. Another possibility, the check valves very often develop a lot of carbon in them, so they may either not have the one-way direction function or may be blocking airflow. I've definitely seen a lot of carbon buildup in check valves. And other than that, that pretty much covers it, so you know kind of where to check. But certainly the air pump is a great starting point. The truck that will be coming in, I believe, is going to have some type of control problem here, so it should be a pretty good case study, but I've never seen that before, actually. Another thing to keep in mind is the variation you may find in some systems, particularly after the control valve. I have seen some cars, usually older ones, where the air system does not inject into the exhaust manifolds, but rather directly to the catalytic converter. So if you know the car has an air system and you do not see injection to the exhaust manifold, then you might look for a tube going directly to the catalytic converter. That would be the air output hose. And also keep in mind that on many older cars, like we're talking, in the early 80s and stuff like that, I remember having a Ford F-250 with this situation. The air pass system has often been bypassed by owners because they had problems with the air pump system and just, getting rid of the system altogether. So keep that in mind. In many states, that is actually illegal and would cause a failure of emissions. I know in Missouri that was definitely the case for one truck that I worked on. So do keep in mind, because people don't understand the system, very often they just get rid of a system that causes problems if they can. So just keep that in mind. So at this point, I think what we'll do is go and see if we can identify some of these components in my car based just off the fact that we understand the system, even if we may have never seen any of them before. I personally actually have never seen the air pump in my car. I actually don't even know where it is, but I'll bet, given the fact that we understand how it works, we'll be able to locate it just based off of that. So as an advanced do-it-yourselfer, what you don't do when you look at this mess of spaghetti to find the components of a system you're not familiar with where they're located, you don't go on to one of those stupid forums and ask, where is my air pump? Because what's going to happen is the Haynes manual jockeys there who never even heard of that before, but they don't want to look stupid, will grab their Haynes manuals, look it up, and find that the location is somewhere here or there, and that's what they will tell you when they don't even know what an air system is. For us, because we know what the air system is, we can work in reverse. Because we understand how it works, we know that if we start here at the exhaust manifold, we should be able to see something that would be with the air system. And as we can see, there is a pipe right there on the exhaust manifold. There's actually another one directly adjacent and lower to it that also goes to the exhaust manifold. Let's follow that one, and it follows up to here, which is actually an EGR valve, an electric EGR valve. Now, how do we know that that's not part of the air system, even though it connects to the exhaust? Because there are no tubes connecting to an air pump. This tube up here goes to the intake, and I know we haven't covered EGR. We'll cover that on another diagnosis and understanding. But based on our understanding of the system, there is no reason we would have a tube going to the intake manifold on an air system. So even if we didn't know that this was the EGR, we would dismiss this. Now let's look at this other tube right here, and let's follow it. And it goes to what clearly, right here, must be a check valve. And then if we follow back behind the cowl, it rolls back over to here, and it ends at this UFO looking thing with two other hoses coming out of it. One of those hoses goes to what clearly is another check valve. And if we follow that, it goes to the other bank on the exhaust manifold ultimately. So obviously this is our air system. We can also see on our UFO looking thing there, which is obviously the control or diverter valve, there is a vacuum hose on top of it. I'll bet that vacuum hose goes to a solenoid. If we follow that vacuum hose, we can see with the blue electrical connector and the yellow clip there, that is clearly a solenoid. There are two hoses connected to the solenoid there, two vacuum hoses. One, of course, to the valve, and the other one is, of course, going to go to vacuum. Now, if we look at our diverter valve, there is, just like on our diagram, a third hose. Where do you think that has to go to? Of course, it has to go to the air pump. So now we'll be able to find our air pump without consulting a diagram or some Haynes manual jockey on Yahoo. So let's follow that. And it kind of disappears a little bit behind the brake booster, but there it is. It appears right here at the front of the car, which is promising actually. But then to my misfortune, it looks like there it is right there. It's going to disappear through that hole to the bottom of the car, and actually it looks like that's an air pump right there, kind of in that gap by the fuse box here. That's clearly the air pump. So I don't feel like removing the fuse box. I think we'll go under the car and see if we can examine that air pump. And my bet is it's going to be behind this little access panel here, because this seems to be right under where that tube ended. And if we look up in there, let's see if we can get you a shot of that. I will arrange a better shot, but that right there is indeed the air pump. So let's go ahead and do an electrical test on that. I'll see if I can work the camera work out here a little better for you, and we'll come back. So sorry for the camera work here, but what I've done is I've got the connector right here directly for the air pump motor. And let me fix this shadow here. Sorry. You got to keep in mind that I am on the garage floor, which happens to be probably 25 degrees right now. So do keep that in mind when you ask me, hey, when's your next video coming out? It'll be coming out when I feel like laying on my 25-degree garage floor and taking my car apart for no other reason than to just show you this stuff while you are in bed with your iPad watching it comfortably, hopefully with both hands on your iPad. But what I'm going to do is I'm going to feed a little extension wire here to the connector for the power. And I also have one here for the ground. And all we're going to do is just apply battery voltage directly to this motor. And this should be very standard for you guys. And what I'm going to use is, once again, you've seen this before, my power probe, but you can easily just do this with jumper cables. All this is just connecting the ground and power directly to the battery. And when I put battery power to this, we should hear the motor start. And you can certainly hear that. So putting 12 volts to the motor does operate it. In a diagnostic situation, this would be 100% confirmation that the motor is not the problem. Now, we might check if the motor is getting power while we're down here. That would be the next thing that would seem logical.